Okay, this is lesson 6.2, and this is about rates of change. In the last lesson, we were describing rates of change as constant or zero, like as if there was no rate of change, it was flat, or changing, so increasing or decreasing. Today, we're going to look how to calculate it. So the rate of change is just the rate or quantity at which something is changing, and it's often indicated by the slope of a graph. So how do you determine slope? Well, if you have a table, let's make up some numbers for our table. Say 4 and 6, 10 and 18. If we're looking here, if we want to find the slope, we're looking for the change in y over the change in x. The change in y is just how y is changing. Well, y is going up by 8. How is x changing? It's going up by 2. So if we wanted to find the slope here, we would just do, well, I'll say m for slope. We would do 8 divided by 2, which is 4, and that would be our rate of change. This triangle is delta, and delta means change. On a graph, we would take 2 points off of our graph. So let's say a point here and a point here. And we would need the x and y values. So let's say that's 4 and that's 8. We'll call this 10. We'll call that 18. If we want to use a graph, we have to look at the rise and the run. So how do you find the rise and the run? Well, the rise would be how much the y is changing, and we're going from 10 to 8, so we're going up 8. I don't know why I changed that number. Let's change it back, make it 6, so it matches the other. The scale's a little weird now, but it's okay. So rise and run. We're going up 8, and our run from 4 to 6 is going up 2. So if we want our slope, we just do rise divided by run, which would be 8 divided by 2, which is 4. Same as the other one. So rate of change is just the slope. So it's the rise over the run, or it's delta y over delta x. Change in y over change in x. All right, so let's do 2 examples. Calculate the average rate of change between each pair of points. Explain the rate of change. So we have a table here. So we're going to do the change in y and the change in x. Pretty easy to see the change in x. We're just going from 0 to 4, so that's up 4. Airplane height, we're going down. So we're looking for a negative answer. And the way we can find it is we do 1400 subtract 2000 in a calculator. We would get negative 600. Or you might be able to look at these numbers and say, what's happening from 2000 to 1400? Well, it's going down 600. So if we want our rate of change, we do the change in y over the change in x, negative 600 over 4. And if we do that in a calculator, we get negative 150. Now that negative 150 doesn't really mean anything unless we can explain what it means about the altitude of the airplane. Well, to do that, we take the units and we put them where they are, where they should be. So we've got meters for height and minutes for time. Well, meters for height should be with the y, and the y is on top, so we've got meters. The time is the x's, so it should be on the bottom. We got minutes. And now our units are just meters divided by, per minute. And now it gives the rate of change a little bit more context. What's happening to the airplane? It's going down 150 meters per minute. And that's how we describe what a rate of change means. We put our units on it. Let's try B. Vehicle rental costs. So we got our rental cost and our distance driven. So this time we have a graph. So if we want the rate of change, we're going to have to do rise over run. So what's our rise? Well, we're going from here to here. That's 400 and that's 700. So our rise would be 700 minus 400 because we're going up So our rise is 300. Our run is going from 200 to 400. So again, going up. So our run is 400 minus 200, which is 200. So now we got our rise and run. 300 for our rise, 200 for our run. And if we divide them, we get 1.5. What's that mean? Well, put our units. The Y's, or the rises, are costs in dollars, so that's $300. And our run is in kilometers. So we got kilometers. So our answer is $1.5 or $1.50. And then divide by kilometers means per kilometer. So what's this mean? Well, if it's about a vehicle rental, it means that to rent the car, it costs $1.50 per kilometer. All right, let's flip the lesson over. All right. The distance required to stop a car depends on the speed at which the car is traveling. Use the tables below showing the reaction distance and braking distance needed to stop a car on dry pavement to answer the following. Calculate the average rate of change between consecutive points in each table. Describe the rates of change revealed in each table. All right. So we can do this if the speeds are going up by the same amount, and they are every time. So if we want to find the rates of change, we're just looking at the change in y divided by the change in x. So what's our change in x? Well, it's going up by 10 every time. And our change in y? It's going up by 2, up by 2, up by 2, up by 2, and up by 2. So if we wanted to find our rates of change, we would take each change in y and divide it by the change in x. So it would be 2 divided by 10 would be our first pair, and then 2 divided by 10, and then 2 divided by 10, 2 divided by 10, 2 divided by 10. They're all the same. 0.2, 0.2, 0.2, 0.2, and 0.2. So what's this mean? Well, this means that we have a constant rate of change. So that means we have a line. In fact, this line represents the graph below. So this is an example of a linear relationship. Now I've kind of spoiled the next one. If we look at the next one, it's a curved relationship, and it's curved and it's increasing. So if we look at the rates of change in our table above, we should get rates that are increasing. Well, let's find out. What's happening to our x's? Well, it's going up by 10, and then up by another 10, up by 10, up by 10, and up by 10. And our y's, what's happening? To do a little bit of mental math here. Up by 0.5, up by 1.5, up by 2.5, up by 3.5, and up by 4.5. So our rates of change, we're going to take our changes in y and divide them by changes in x. Our first one is 0.5 divided by 10, and then 1.5 divided by 10, 2.5 divided by 10, 3.5 divided by 10, and 4.5 divided by 10. And if we use a calculator, we can figure out what those are, or we can just move the decimal one place because we're dividing by 10. So 0.05, 0.15, 0.25, 0.35, and 0.45. Look at our rates. Our rates start at 0.05 and they go up, and then up, and then up, and then up. So what's this mean? Well, this is a increasing rate of change. And this means it's non-linear. And this is an example of this graph below. We have a non-linear relationship because our rate of change is increasing. If the rate of change is constant, we have a linear relationship. All right, last page. Let's look at a tomato plant. Identifying rates of change in a table and a graph. The table below shows the rate of change, or shows the change in height of a tomato plant from germination until the tomato ripens. So we've got our table. Let's graph our points and see what we've got on a graph. So we've got 0, 0. 2 is 5. 4 is 10. 6 is 20. 8 is 40. 10 is 58. 12 is 75. 14 is 86. 16 is 90. And 18 is 90. So we get this shape. And I'm just going to go ahead and I'm going to attach these dots with a smooth curve. So we can kind of see what's going on. There's the growth table and growth graph of our tomato plant. Well, we can look at our table and we can figure out the rates of change. If we compare the change in height to the change in time, we are going up 5 and we're time's changing by 2. Our next pair, we're going up 5 again and our time's changing by 2. Next pair, we're going up 10 and our time's changing by 2. Next time we're going up by 20 and our time's changing by 2. Then we're going up 18, time's changing by 2. Next one's 17 by 2. Next one is 11 by 2. Next one's up by 4 in 2 weeks. And the last one's up by 0 in 2 weeks. So these represent our rates of change. And this should shed some light onto what's happening with our plant. 5 divided by 2 is 2.5. 2.5. 5. 10. 9. 8.5. 5.5. 2, and 0. What's this mean? Well, this is in centimeters for height per week. So 2.5 centimeters per week in the first 2 weeks, and then 2.5 again, and then 5, and then 10, and then 9, and then 8.5, 5.5, 2, 0. So these are our rates of change. So now we can answer some questions about the tomato plant. When's the rate of change 0? Well, the rate of change is 0 at the end, between weeks 16 and 18. If we're just looking at the graph, we'd be looking for where the graph is flat. Where's the rate constant? Well, we look in our table, 2.5 and 2.5. That's the same number. Nowhere else is it the same number. So we say between weeks 0 and 4. Constant means you're looking for linear. And finally, changing. Well, we're changing from basically here to here, all the way to the, basically between. So from 4 to 16, everywhere in between, we're changing. And that's where you're looking for nonlinear. So if we were to describe what's happening, we can use, when is the rate of change the greatest? We just go through the table and look for the biggest number, 10. And 10 is from between weeks 6 and 8. So 6 to 8 weeks. All right, so if we're going to describe the trend, we're just going to use these rates of change and describe the tomato plant. Well, what happened at the beginning? Well, the beginning was this 0 to 4 weeks. What happened? We were increasing at a constant rate. Now the middle section was this non-linear section. We kind of have two parts to the middle because we're curving up and then we start curving down. So as long as the rates of change are getting bigger, we're curving up. So 2.5, 5, 10. So this section here from 4 to 8 weeks, the numbers are going up, and then they start going down from 8 to 16. So we say from 4 to 8, 8 to 16, and then our last section 16 to 18. So from 4 to 8 weeks, we're still increasing. In fact, we're always increasing, except for at the end. And at the beginning, we're increasing at an increasing rate. And that's because the rates of change are getting bigger. In the middle here, 8 to 16, we're still increasing because the numbers are getting bigger, the plant's getting bigger, but we start to slow down. Decreasing rate. And from week 16 to 18, no growth. That's because we've kind of reached the maximum height of the plant. And really quickly at the bottom here, let's summarize. So if we're looking for zero, rates of change, constant, and changing, the first differences will be 0 for 0, constant, they'll be constant, and changing, they'll be changing. That wasn't super useful. On a graph, 0 will be flat, constant will be linear, and changing will be not linear. I wrote that up there. All right, and that's it for lesson 6.2. Thanks for watching, and I'll see you in 6.3.